The Python variables that we've met so far have mostly been numeric types, like whole numbers or decimal numbers. But Python has many, many different types of variables. This video is going to be about Boolean variables which represent true or false. We can create these using the keywords true with a capital T and false with a capital F. So in this first code cell, I'm creating two new variables called P and Q, and P will have the Boolean value true, Q will have the Boolean value false. Incidentally, you can check the type of any variable in Python using the type function. And if we do type P, you can see it prints out bool because P is a Boolean variable. So bool is short for Boolean. As well as having the Boolean type, Python has logical connectives for working with Boolean types built in. The logical connectives it has are and, or, not. So for example, if we do P and Q, well, P is true, Q is false, so true and false is false. And that's indeed the answer that we get. On the other hand, P or Q is true or false, which is true, and P is true, so not P will be false. So while Python has and, or, and not, it doesn't have implies built in, but we can define an implies function ourselves. To define implies, we need to remember a logical equivalence, which is that A implies B is logically equivalent to B or not A. So that enables us to define the implies function using the built-in or and not. So implies AB should be B or not A. And that's it. We can now use implies. So in our code cell just here, I'm going to print out the whole truth table for the implies function to see whether it works or not. And you can see what we got was true, false, true, true. That's the correct truth table for implies. The only time it was false was the second piece of output, which here is true implies false, which is what we expect to be false. Okay, so we can create Boolean variables with a particular value by just using assignment, as we've seen. You can do P equals true with a capital T or P equals false with a capital F. But Booleans are usually created in other ways. For example, through doing comparisons, like asking, is a number A greater than a number B? Or is a number A equal to B? Or is it less than B? Or greater than or equal to? All of those things are statements which are going to be true or false, so they'll have a Boolean variable. So let's see how we can get those Boolean results of a comparison in Python. And the answer is that if you want to do greater than or less than, you can do that simply with the greater than or less than sign. So when I execute this code cell, which contains 1 is greater than 0, this will give me a Boolean value, specifically the Boolean value true, because it's true that 1 is greater than 0. And here is how to do less than. If you want to know whether 1 is less than 0, you can type 1 less than symbol 0 and run the code cell. Of course, that will be false. So that's less than and greater than. On the other hand, if you want to do less than or equal to, or greater than or equal to, you can do that using a less than sign and then the equal sign, or a greater than sign and then the equal sign. So let's have a go at doing that. In this code cell, I've defined two variables, A is equal to 1, B is equal to 2, and then on line 3, I'm going to do a comparison. So I'm asking Python, is it true or false that A is greater than or equal to B? Of course, this is false, so it will give me the answer false. On the other hand, if I ask, is A greater than or equal to A? So is that true or false? That will, of course, be true. So we can now do less than and greater than, and less than or equal to and greater than or equal to. But what about equality and inequality? Now there's a slight problem here because we have already used the equal sign for something other than equality testing. We use the equal sign for variable assignment. So it's very important to remember that there are two distinct usages here. So doing a variable assignment is different from checking whether two things are equal. So look, for example, here at this. If we want to do an equality test, we must use two equal signs. So the code cell I'm about to execute is asking, is 1 equal to 0? That will give me a Boolean value. In fact, it will give me the Boolean value false because 1 is not equal to 0. On the other hand, we had a variable called A, and if I ask if 1 is equal to A, that will give me the value true because A did have the value 1. Again, just to emphasize, a single equal sign is a variable assignment. It is not an equality test. So when you do 1 equals to 0, that is going to be an error because this is a failed assignment. It doesn't work as a variable assignment. What is on the left-hand side there is not a legitimate Python variable name. So this is an illegal attempt to do a variable assignment. You'll see here that we get an error and it says can't assign to literal. What it means is using 1 equals sign means you're trying to do a variable assignment, but what you've got on the left-hand side of that equal sign is not a variable name. In fact, it's a number. This is particularly important because it can lead to mistakes which are quite difficult to notice. So remember that we have 2 variables at the moment. A is equal to 1 and B is equal to 2. So if I wanted to check whether A was equal to B and I accidentally typed A equals B, then what I'm doing is not going to produce an error. Instead, what it will do is just change the value of A. So it will assign the value of B to the value of A. And once we've run this, A will now have the value 2. If you were instead intending to check whether A was equal to B, then you've made a big mistake because instead of doing that, you've just changed the value of A. So this will not produce an error, but what it will do instead is change the value of A. And of course, if we now think, oh, well, what I meant to do was this, thinking A is still 1 and B is still 2, we'll get this very confusing result of true. And the reason for that is what happened in the previous code cell here changed the value of A, so it was the same as the value of B, so that A is equal to B is true. Okay, let's do one final equality. So Python doesn't distinguish between 1 divided by 2 and 0.5. Those two things are equal according to Python. So here we checked using the double equal sign to see whether they were equal or not, and the answer was that they were. Finally, the only comparison we've not yet done is not equal to. And in order to do not equal to, you use an exclamation mark and then equals. So you should think about that as looking a bit like an equal sign crossed out, which is the thing that we normally use for not equal to. For example, 1 exclamation mark equals 2, that is asking, is it true that 1 is not equal to 2? Of course, it is true, so this will give us the value true. But if we check whether 2 things which are the same are not equal, of course, we will get the answer false. So true is not equal to true is false.